Hi everyone, thank you for coming to my talk today, From Zero to Hero, Coder's Archetypal Journey. If you haven't already been welcomed, welcome to JavaScript and Friends, and I hope you're enjoying the conference so far. So first off, a little bit about me. I've been programming since junior high. I love to play music, I love to listen to music, I play guitar, a couple other instruments. I love JavaScript. Before my current job, I had kind of worked in the .NET and WordPress for both sort of client and marketing work. Now I'm a JavaScript developer and I absolutely love it. It's just an awesome language. I really like that you can use it for full stack, right? So I can use JavaScript on a website, I can use it on a backend project, I can use it on a personal project. It's awesome. I work at a company called Rove. Our mission statement is to expand ownership in people's communities to people who are renting, people who are more than just homeowners. Check out our website. Some technology that I use at work, just as an idea of the background I work with on a daily basis, is Gatsby.js, which is a static site generator using JavaScript. JavaScript, obviously. Contentful, which is a CMS backend for content management, and React.js. So the goals here today is by the end of this talk, you'll understand how to grow as a programmer. You'll understand the need to have a common vocabulary between programmers, between developers, between people on product team. I think a lot of times people miss out on the importance of having a vocabulary and a terminology that they can use to talk with their coworkers to describe code and issues they're having. And almost most importantly, be able to answer the question, how does one learn to program? I'm sure as a programmer, a lot of people get asked from friends, family, etc., how do I learn how to program? It's a tough question to answer. Oftentimes, the answer is kind of just go to Google, follow some tutorials. But there really is a good route to take. It doesn't have to just be go to Google, right? There's a path you can take, and I think that many times as developers, we ourselves forget that we're also learning and that we have a path we need to take as well. So the first question I want to ask you here is what's a sandwich? It might sound like a silly question, might have nothing to do with programming, but when you think of a sandwich, what pops into your head? Is it two pieces of bread? What is it? If you search sandwich on Google, this pops up, all sorts of pieces of bread with meat in them, maybe some vegetables. But we also have a chocolate sandwich cookie. That's maybe not the same thing as a Italian sub sandwich. An Italian sub sandwich isn't the same thing as a grilled cheese, right? But we all recognize them as sandwiches. Maybe even a little bit more philosophical, is this a sandwich, right? We've got two pieces of chicken with some bacon in between them. Our brain sees that, and maybe it's easy to recognize that as some sort of a sandwich, but it's not two pieces of bread. What exactly is a sandwich? Is a sandwich a strict definition? And even more abstractly, what pops into your head when you see this? Probably sandwich. Uh, you know, it's pretty abstract though. To be quite honest, I don't think I've even ever had anyone hand me a sandwich with an olive on it. But our brain recognizes this sort of abstract sandwich that is in some ways a representation of the set of all sandwiches. And we call that an archetype. So I want to go into a book here, give some description of the book, and that will kind of lead us into what a good definition of archetypes are and where they come from. There's a book by a man called Joseph Campbell called The Hero with a Thousand Faces. In short, it's essentially a book or collection of studies on what is called comparative mythology. Comparative mythology looks at stories from across lots of cultures, whether it be modern day different cultures or past day different cultures, and finds common threads in these stories and kind of shows the similarities and shows kind of the generic story that might be shared with them. And the book, The Hero with a Thousand Faces, Joseph Campbell starts by going over one particular story that is called The Hero's Journey. So here's a description of what the hero's journey is. A hero ventures forth from the world of common day into a region of supernatural wonder. Fabulous forces are there encountered, and a decisive victory is won. The hero comes back from this mysterious adventure with the power to bestow boons on his fellow man. So, stories across all cultures have similar recurring themes called archetypes. Archetypes are agnostic to language and culture. So this kind of story of a hero's journey that we hear about an everyday man who gets a call to adventure, who maybe has some divine help, think Frodo and Gandalf. You know, he goes and he slays the dragon and he comes back to his hometown and he's a hero, right? He's changed. He's not the same anymore. These stories are archetypes and they are representations of universal truths and ideas. Think good versus evil. Maybe the story of a cookie jar, right? Don't be greedy. You know, there's a cookie jar and the mouth of the jar is too thin, right? So maybe you can tip over the cookie jar and get one cookie out of it. But if you tip it over, if you stick your hand in it and just try to grab a cookie, it's your hand's going to get stuck, right? So it's a moral lesson there. But it's also a moral lesson that many times gets abstracted into a much longer story. The story of Icarus. Pride comes before the fall, right? He flew too close to the sun. There's lots of stories that have shining similarities between that story and Icarus. And it's the same idea, it's the same lesson, which is pride comes before the fall. So I would ask you, what recurring themes can you think of from your favorite stories? So why do we care about these archetypes, right? Well, for one, archetypes are a good way to take abstract ideas and put them into concrete terms, right? It's hard to maybe point out what sort of a story Lord of the Rings is, or what sort of a story Cinderella is. But by having these concrete terms and recognizing these abstract ideas, we are able to discuss them more easily. Uh, Easier story writing, right? So if I'm familiar with a lot of archetypes, with a lot of different stories, it gives me in my head kind of a framework for writing stories, a way to write stories that is a little bit more of an approach and isn't just sitting down and waiting for something to pop into your head to make the blank canvas not so blank. Familiarity. So you know, by recognizing these stories, we can recognize what ones we're familiar with and draw our experience from them. And then I've already touched upon it a little bit, but most importantly is analysis. Analysis is essentially that because we are able to recognize these terms, we're able to look at them, we can analyze these stories, we can analyze lots of stories in the context of maybe their archetypal description, right? So maybe we can analyze Lord of the Rings in the context of the hero's journey. That gives us a bit more insight into it, and it gives us a better way to critique stories, to look at what they could have done better, to maybe look at what sort of novel ideas this story brings. So I'm going to introduce a new archetype to you here today, and the archetype is named Steve. He's a college graduate junior level developer, codes as a hobby, and landed a job writing code for a big corporation. He is the archetype of a junior developer. He loves JavaScript, But when he talks to his coworkers about code, he notices that unless if he has an IDE open, he can't really seem to describe what's happening. Right? He can say, "Oh, I have a class that's called this, and this class is this methods, and it does blah blah blah." And by the time he's finished telling his coworker what the class is supposed to be doing, they have no idea where he's at. He has to pull up his IDE, he has to show them the code, and then maybe they recognize what's going on, but it's still a tough time. He wants to go from junior to mid-level to senior, but he doesn't even know where to begin. And this is where I want to go to the next step here, which is that sometimes knowing the path is more important than knowing your current location. So, if I go on a trip where I'm going to go on a hike, I'm going to have some route for that hike. I'm going to have a path I want to take. I'm going to have a compass, right? I'm going to have some sort of GPS system, but I'm also going to know where I'm headed, right? If you're walking up a mountain, your goal is to get to the summit of the mountain, and you probably have a path that you're going to take to get to that mountain. And even then, more often than not, that path has already been taken by other people. You don't need to necessarily forge your own path as much as you do look at the other path and follow it. That's not to say you can't bring new novel ideas to your path, but it is to say that if you don't have any idea of where you're headed, of the route you need to take, it's very hard to go from junior developer to mid-level developer to senior developer. So I'm going to bring in what I like to call the pyramid of programmers. And this is essentially a hierarchy of different levels of programmers that we oftentimes see in companies. You can think of each level of this pyramid as an archetype of a type of programmer. The first type of programmer I would bring up is what I like to call the freshman. Uh, this is someone who's basically brand new to programming. Maybe he knows what a class is, object-oriented programming. He can maybe give you the Webster's dictionary definition of. And when the freshman is learning, they really learn algorithms before syntax, right? So they might be only working in one language, and every time they want to do something, the question isn't even what language should I use to do this, or how do I even do this in this language? It's really how do I do this at all? Maybe they don't know what a for loop is. They don't know what a switch statement is. So this is kind of someone who's brand new to programming, isn't really in a career for it. Maybe it's just a hobby. Maybe it's just something they're passively interested in. Next level is the student. At a company, I would say that this is like a junior developer role level. For the student, learning is about keeping up with the code that they're working on. It's not necessarily about improvement. Learning for them definitely is improving their skills, but the learning they're doing is really just so that they can do their job at a base level, right? They're maybe not learning how to necessarily pick up skills that they may not be using. Almost everything they're learning is likely something that they need to know to be able to do their job. While it's no, condensation to junior developers, they're definitely less efficient at writing code. I would say a sign of a good developer is that they're not afraid to ask questions. So the difference between a freshman and a junior developer here is that, a junior developer can write code, they can be productive, but they're also wanting to learn. They're showing a proactive interest in programming. Steve is here. Steve is at the junior developer role at a company. He is at what I would call student. The next level here is the developer. I would say this is where I'm at. This is where a lot of people are at. This is at a lot of companies called a software engineer level. A developer has learned design patterns, hopefully knows how to implement them. Developer should know how to abstract appropriately. He should be able to look at a code base and know when to pull out code. He should also know when to look at a code base and know that something maybe doesn't need to be abstracted, right? As a lot of times as an early developer, we have what's called a golden hammer. We want to over abstract everything we're doing, and everything ends up essentially being too complicated because we're not just trying to solve one problem, we're trying to solve all problems. And if you're trying to solve all problems, obviously you'll never finish it. So the developer knows when to abstract, but they also know when not to abstract. One big difference between the developer and the student is that the developer sees opportunities for code improvement. He can look at a code base and know when something is off. Uh, we can know when something has what a lot of times we call a bad code smell. Above the developer, we have what I like to call, or a lot of people would call, the architect. This is probably a team lead level, maybe at a company you're working at. They can do a refactor on code without having to feel that they need to rewrite the entire code base. So oftentimes where the student is less efficient, the developer is kind of, just the average efficiency of a programmer. I would say that architects are incredibly efficient when they write code. If anything, they probably spend a lot less time writing code and probably a lot more time thinking about code. They think of how they want to write their code, how they want to architect it, and then they write it down and they make it happen. Along with these development skills, an architect should also be able to translate what I would like to call customer speech. That is to say, an architect should be able to know about more than just programming alone. An architect should be able to, talk to a customer, talk to, a product owner, and kind of figure out what features need to be implemented in a program to meet those customer requirements. A lot of times, this is a skill that I think is missing in mid-level developers. Someone comes to them and says, I want feature X, and they say, okay, well, we'll build you feature X. An architect would hear from a customer, I want to build feature X, and say, well, what are you trying to accomplish? From there, they would then decide, does the client actually need feature X? Maybe the client actually wants feature Y, or the client actually wants an already existing feature to be more prominent, right? So they have some extra skills that are about more than just the code itself, but are about architecture, building the code, and knowing what to build. And the last level, the highest level, would be what I would call the guru. This could be a CTO, probably a CTO at a smaller company, maybe a startup. I think a lot of times CTOs at really large companies are more, business focused than they are necessarily technology focused. So I would say that CTO wise, this is probably at a mid to small level startup. The guru has a high level of domain knowledge. So not only does he know how to program, he knows how to use his tools really well. The guru probably doesn't have to go on Google and look up what sort of methods he can call from an API. He might go to Google and look up how have other people done this so that he can compare it, right? He might look up what's the most efficient way to do something, but the guru probably isn't looking up how to do it because he doesn't know. If you have a product you're working on, the guru should be able to rebuild that product from scratch. He has an intense knowledge of the product from the front end, the mobile app for the product, the website for the product, or the physical object for the product, all the way to the back end level for the product. And he could probably rebuild almost all of those items from scratch. Obviously, it would be a big effort, but he has that level of knowledge. And most importantly, and I think the sign of a really good programmer is that the guru builds products not code. So what does that mean exactly? Well, a lot of times, developers, they want to write good code. Maybe they want to implement certain patterns. An architect might be concerned about the best way to write the code, right? They might be concerned about making sure that the code has all the features that the customer wants. But the guru is really focused on the ultimate end product that is resulting from the code. If the guru recognizes that he doesn't have to write code to build the product that the customer wants, the guru is okay with saying he doesn't need to write code. Now, maybe that sounds a little silly, right? A programmer who doesn't want to write code. Well, the point I'm trying to make here is that the guru recognizes the most efficient way to do things, and he sees the way that people have done things in the past and tries to draw experience from that. So I hope you can see here that there's a natural progression we kind of want to follow as a programmer. I want to now define a timeline of what that natural progression looks like. Over here, we can see that someone will start as a freshman, right? And this is someone who isn't yet in a career, they aren't yet hired. They're mostly going to be learning from books, hobby projects, and entry-level tutorials. I think it's pretty straightforward, and most people kind of understand this progression. From there, we go up to a student, which is someone who is probably hired somewhere working as a junior dev. The things that students will want to focus on is going to be learning terminology, kind of domain expertise type terminology, design patterns so that they can learn, kind of abstract programming, and really just experience with client work, right? Nothing is better than actually building a project from start to finish as a professional developer. From here, we get to the developer phase, and this is where I think probably most people are. To get from the developer to the architect phase, the sort of things I see a developer doing would be legacy code work, which involves working with older, larger, more complex code bases a lot of the time. Mentoring other programmers, mentoring junior devs that come into the company, and then building common libraries. I think something that is a sign of a decent developer is that they, especially in their hobby work, might find common functions that they're building, common items that they're using, and maybe extract that out into a library that they use for their own personal work across projects. In similar manner, in their professional job, if they find that they're using the same thing over and over in multiple projects, I would hope that they would have the experience and skill to know how to take that and pull it out. From there, we have architects. Architects, to move up to what I would call the guru position, are going to be leading teams, right? This is probably a team lead level position. Project management. So again, another thing that's kind of meta code, right? Outside of coding, but is still intimately involved in the process. An architect is going to be really good at knowing what phase of a project needs to be worked on and how that project needs to be split into smaller, more sizable tasks. And perhaps community involvement. Many times an architect is going to do mentoring probably on a larger level. They might be speaking at conferences, mentoring lots of younger developers, maybe a YouTube channel, maybe contributing to open source, right? And from there, we get to the guru. He's going to have usually a rich full stack knowledge. They're going to be leading multiple teams, maybe a CTO level. And a guru is really going to have a lot of product knowledge. So they're going to be the type of people where you come to them and you say, what is it that the client or the customer or whatever we are building for, what are they wanting to have in this application? I think from freshman to student here, we have, kind of this just interest in programming and career growth sort of natural progression. It's not very hard for people to go from a passive interest as a freshman to becoming a student. On the other side here, we have passion, going from an architect to a guru. These are people who are really passionate about programming, about coding, about what they do, and they're going to kind of take the next step in their career just through their enjoyment of what they're doing. So I think there's a progression here from freshman to student, and also a progression from architect to guru. I want to identify in this talk what I call two different gaps here. What we'll be referring to as the blue gap and the green gap. And the blue gap is how someone as a junior dev makes the leap to a developer role. Many times the struggle with junior devs isn't that they don't want to become a mid-level developer, but they don't even necessarily know what they don't know, and they kind of have a hard time identifying what's more important. Should they be learning design patterns? Should they be learning new frameworks? Should they be learning a different language? And on the other side here, we get to the green gap, which is going from developer to an architect. And I think this is kind of a similar problem, and probably even more so of a problem that people encounter, right? A lot of people will spend their entire career at this level as a developer and might never go to this team lead architect role. So in these next slides, and really the rest of the presentation, I want to go through kind of the steps you take to go from a student to a developer and cross this blue gap, and to go from a developer to an architect and pass this green gap. And hopefully through this, you'll see the natural progression that this developer Steve we're following will be taking to get through his career. So the first item I want to approach here in crossing this blue gap is what I would call domain expertise. Kind of here's what I would call in many ways a summary of working as a junior developer. You're usually going to be, good at syntax. They know how to write basic JavaScript, basic Java, HTML, whatever it is they're writing, but they're kind of always Googling API documentation. They're always trying to figure out how to do something on jQuery. They can write the code, but they don't actually have any sort of expertise in that area. I see a lot of people who are junior devs, but in many ways are still kind of jack of all trades, right? They'll know HTML, they'll know CSS, they'll know JavaScript, they'll know Java. Maybe they were coming out of a tech boot camp type program where they were kind of focusing on full stack development. So they went over a lot of aspects of development, but maybe not a lot of aspects of a small portion of development or how to use specific tools in a language. The next steps that we take here are going to require more than just broad knowledge, right? So a good developer, the next level of junior dev, I want to be specific here. Like good developers aren't tied to a language. So, a good developer is going to use what the best tool is for the job. But I think a lot of people here mistake domain expertise for being tied to a language. That's not true. However, if you really want to excel, you're going to need to have more domain knowledge in a language than you probably have in other languages. So a good developer is going to focus on expertise. Because of this, first off, they're going to be more valuable to their team, right? I think everyone has seen kind of a junior dev come in and you don't know what to stick them on in your project. And that's not because you couldn't stick them on different parts of your project, but that's because they don't necessarily excel at any one thing. Maybe they're okay at front end, they're okay at back end, they're okay at writing APIs or working with databases or whatever, but they really aren't specifically good at one thing. And the issue that you run up into is you don't know what to put them on. So someone who does have this expertise is going to be more valuable to the team because they're going to grow a certain aspect of your product that other programmers might not. A caveat here, though, is that expertise should be prioritized after you're learning general knowledge, not before, right? So if you remember kind of this progression that we went through of a junior dev to a developer, starting out as a freshman to a junior dev to a developer, uh, the freshman stage is where people are going to learn their general knowledge, right? They're going to learn, what a for loop is, uh, what a switch statement is, basic syntax. Even if they're only planning to do front end, they should still have general knowledge of how database works, how an API works, just for the sake that they can understand what's happening. I would ask you this question: do you want a general surgeon or do you want a heart surgeon? Right? People really push for full stack and they push for jack of all trades, and that's not necessarily bad. But if you need a new heart valve put in, are you going to go to someone who only does quote unquote general surgery, or are you going to go to a heart surgeon? You're going to go to the heart surgeon, right? So, in summary, learn some specific tools, some specific things to your language that make you valuable and make you stand out as a junior dev. That's a good way to push yourself into a mid-level role because it's going to make you more appealing to people that want to hire you and to teams. And it doesn't even have to be extensive, right? A good example here would be someone that works with HTML and CSS and uses jQuery, right? But anytime they use a jQuery plugin, it's just kind of a magical black box, right? They couldn't write a jQuery plugin themselves. They really don't understand what prototyping is. So they're kind of using these tools, but they don't know how they work behind the scenes. They don't know how to extend them. Even just a simple level of progression and domain knowledge in a language and a framework is going to really excel you as a junior dev into someone who can be at a mid-level role because it's going to make you more valuable to a company than just any person who knows how to program. So kind of building off of this domain expertise is the next uh, learning phase I would say people need to take, which is terminology. And terminology is a vague expression, right? But the intent here is that a lot of times when people learn how to code, they learn kind of basic programming terminology, but they don't learn really the terminology that they need to know for really specific things. So I wanted to go through here an example of the type of terminology that would be important for a junior developer to learn. And that would be closures. Closures are very common in JavaScript. Essentially, a closure is a function inside of another function, right? So here we have a function called getValue. Inside getValue, we have a variable scoped to getValue. And then inside getValue, we have a function that we've called closure function. And it uses this outer scope variable's value and concats that to the end of B and returns that. We can see here that once we get outside of the closure function, we can't access variables inside of the closure function, right? So this scope is essentially closed off from the rest of the function. And here we can see that uh, we can return the values returned from this closure, right? So if I were to return a call of closure function, it would return BA. And if I were to return outer scope var, obviously it would just return A. So summarize, a closure is a function inside of a function. Variables inside the closure function are kept hidden from the scope of getValue. But at the same time, the closure function itself can access variables scoped outside of it, right? So any consts I had up here being a get value, a closure function could use, just as if it were a different part of this get value function. So an example of where a lot of people run end closures is anonymous functions. I think almost everyone has actually, seen this if you're doing kind of modern JavaScript development, which is you have an array and you're calling array.map, and you're doing a function that, right, is returning x times 5. This is called an anonymous function. It's passed to the array.map call, but this function here, the anonymous function, is actually a closure. So while you might be saying, okay, now I can call it a closure, so what? There is a purpose here in that this gives you a way to talk with other developers about what that function is. Another usage of closures is for encapsulation. So you see here we have a block of code called user service. User service takes an API key and sets that API key for the instance and provides us with a function, secret database call that takes a name, some user data, makes a post to a server with the API key in the header, and returns the response that is received from that server. This function that we instantiate, this module, gives us a create user function that calls that secret database call function that we've set up that takes advantage of the API key that we passed when we created this instance of user service. So we can see here now we have const users equals new user service. We pass it our API key. And then we can call users.createUser, and it calls secret database call. A secret database call in this instance is a closure. So Steve says in response to all this, I've been using closures all along, I just didn't know what to call them. And I think that's kind of a common experience here, right? As a junior developer learning terminology, it's not necessarily about learning new things themselves, as much as it is learning what to call them. Remember when we talked about these archetypes, a lot of people have already heard these stories, but maybe they don't know how to refer to that type of story. They don't know the name for the archetype of that story. Knowing your terminology lets us know these archetypes. And so taking terminology to the next level, we have design patterns. Design patterns are the next step of this process. And design patterns are code as archetypes are to stories. They're reusable. A lot of times design patterns are language agnostic in the same way that an archetype to a story was agnostic across cultures. One of the biggest reasons for design patterns is that we can use the same tooling, vocabulary tooling, to describe lots of different projects, lots of different problems. When we're learning design patterns, usually these design patterns are also pointed out by previous developers who are more experienced than us. So it's using to our advantage the wisdom of those who have come before us. In the same way that archetypes help us identify different types of stories as being maybe a more generalized story, being told in a unique way, design patterns help us take what we think is maybe a unique problem in programming and pull it out to be more of an abstract problem. Knowing design patterns gives us a common language to communicate with other developers, with other coders. If we don't have these, it becomes hard to communicate. One of the problems that I had listed of Steve having was that he felt he couldn't talk to other developers without opening up an IDE. Learning design patterns is a really good way for Steve to know how to talk to other developers. So one example here we'll go through is modules. You've probably already used them. They provide encapsulation. They take advantage of closures, which we just learned from terminology, right? So here's kind of the most simple example of a module. You see it a lot in different books, different tutorials, and it's just a simple counter. So it has a local variable here counter, and it can increase that, decrease it, reset it, and it can get the value of the counter. One of the cool things about this module is that it's very similar to a class in that it can be instantiated, right? So this data is encapsulated, it's separated from the rest of your program, and we have several of these counter modules. So let's go to a usage of the counter module. You can see here we've declared a new counter module, we've incremented it, and we've logged the value, which we get out 1. We can reset it, decrement it, and we get the new value -1. The cool thing about modules is that they provide us some separation and some encapsulation, which we can see here. We can instantiate another counter module, increment it twice, it goes up to 2, and it has a separate value from the original counter module that we made up here earlier in the code. You probably already use these in JavaScript. This is essentially how Node Package Manager works, right? Is people release their own modules that they've made that maybe do API calls, that maybe interact with the framework, maybe they just do math utilities for you, maybe they interact with arrays like Lodash. Another usage of a module is that it gives you a cleaner scope. It provides less issues where functions have the same names as somewhere else, and then you run into kind of this clashing in naming, right? So here, if we have this data module that we've made, we can give it this get data function and call data module.getData. And you can see here that it's outputted scoped to module. And then again, we can actually declare another function called getData. This other getData function is scoped globally, and you can see if we call it, we'll say scope to file. Because we've used the module up here to declare this getData function, we don't have to worry about what these other function names are in our global scope. So by taking our code and pulling it out into modules, we can reduce the complexity and domain knowledge needed to process to be able to contribute to the project. This pulls things out into separate pieces, lets people talk about separate pieces of code, and helps just keep things clean and organized. Hopefully, as well, you've seen here that module builds off of our knowledge of closures, right? And that first example I used with closure, we had a module called data service that had a closure inside of it. So this is a really great example of how these skills that we're learning as developers can build on top of each other to take you from this junior dev role to a middle road kind of standard developer position. Learning terminologies and then using those terminologies to learn design patterns gives us a good vocabulary to work with other programmers, and it gives us a common language. We can see now in this pyramid of programmers, as I've called it, that Steve has moved his way up to becoming a developer. At his company, maybe he's called an engineer. Steve still wants to move up. But the problem is that Steve knows, when Steve was a junior developer, he knew not too many other junior developers. most of the people that he knew were engineers, were developer level developers. Now that Steve has become this developer level, he's noticed that most other people are also developers. He's wondering, you know, what does he have to do to take his knowledge and take his career up to the next step? And this is what we call the green gap in this presentation. And the green gap is going from this developer role to this architect role, as Steve is. And it's a tough gap to get across. And the reason being for that is that getting across this green gap is really where you have to take an extra step in your career. You have to really make a lot of extra effort as a programmer. So we're just going to real quickly go over a couple of ways that people can jump from this developer level into an architect level. One of these is refactor, don't rewrite. So should you always refactor? Well, that depends on what your definition of rewriting is. Here we're talking about from scratch versus from existing code, right? So writing something from scratch would be rewriting it, using existing code and pulling that code out into new design patterns, new classes, what have you, is going to be refactoring. The larger the team, the larger the project, the more you're going to benefit from refactoring. So because a large project has so much code going on, refactoring project is going to take a lot of time, but so would a rewrite project, right? However, in the instance where you are refactoring instead of rewriting, you can ease in these changes, these architectural changes, and you can write your new documentation, your new product requirements as you do this refactoring. You don't have to do it all at once. When you're rewriting code, usually you're going to be thinking about the overarching sort of behavior of that system. And because of that, you're not going to actually be able to spend enough time looking at the system you're trying to improve, right? So a really good developer, someone who's coming into this architect role, is going to recognize this. They're going to recognize that if they spend all of their time trying to completely rewrite this system from scratch, almost all their time is going to be spent on just building that base system. And so when they're done, that system might need refactoring in itself. It's also going to ignore sort of a lot of these small nuances or small new client requirements that hopped along when they were making the original code base. Steve has a question here. He says, isn't refactoring more difficult though? Because writing code is easier than reading it. You know, we hear this a lot, right? It's easy to sit down and slam out some code to, set up a new project. It's not easy to go to an existing code base and change it and make it better. And so isn't refactoring going to be more difficult? And the answer here is, well, yes, it is going to be more difficult. But the response I have to that is, quote, from the CEO of Yahoo. She says, I always did something I was a little not ready to do. I think that's how you grow. When there's that moment of, wow, I'm not really sure I can do this, and you push through those moments, that's when you have a breakthrough. So by pushing through these harder sort of development options, Steve can improve his own skills. And at the same time, I think ultimately Steve will learn that he is saving time, he's saving headache on the project. If every project Steve comes to, he feels he needs to rewrite it, to do good work is going to have a tough time being able to contribute to big projects where that's not an option. Kind of in summary here, yes, refactoring might be difficult, but that's going to grow you as a developer. Refactoring, in the same way that design patterns does, takes into account the work of previous developers who maybe talked with the original clients, talked with the original customers, noticed kind of small problems or small edge cases that you might not think of if you're rewriting this code base. And here is something that I would say is really tough. When you work on a personal project, it's easy to want to just rewrite your project, right? But I would really challenge you to refactor instead of rewrite. If you're working on old project you had built, or kind of trying to improve it, because it will force you to review your own code, and it helps you familiarize yourself with situations where rewriting isn't an option. Legacy situations, open source. Another concept here is community involvement. And some options we have here are open source. Open source does a lot to grow you from a developer into an architect, because it's bringing you into a code base where, number one, you don't have kind of this option to just do everything your own way. There's oftentimes stringent requirements of how things need to be done. It's giving you the chance to have your code critiqued by other people, by different developers who would normally critique your code. And is a lot of times can be bringing you into a really large code base. Another aspect of community involvement is mentorship. By mentoring younger junior developers, oftentimes you're teaching yourself new things. You're giving yourself a different light on how programming is. And it helps you improve your abilities to talk about concepts to other programmers, to other developers. So that's kind of the end of the talk for today. And I just want to go to a summary here and go over some key points. Number one, look for and learn common archetypes and vocabularies used by more experienced programmers. So this would be terminology, design patterns, tools that are used. This is going to really put you a step forward in your career. I think a lot of times it's foolish to think that maybe you can do something better than experienced programmers. While maybe young programmers might have a new perspective on things, they have a lot to learn from experienced programmers. Challenge yourself, right? Refactor your code instead of rewriting it. Try to take messy code and make it clean. Be proactive, right? Instead of just coding and coding and coding on these projects for work or whatever, go out there and learn a new framework. If you work with jQuery, go out there and write a plugin for jQuery. Maybe contribute to the open source community. And last but not least, don't be afraid to spend time on domain expertise. A lot of people can be afraid to maybe tie themselves to a certain framework or tie themselves to a certain API. And while that can be scary as a new developer, because you might be tying yourself to certain types of jobs or certain aspects of programming, it's also going to give you these appealing characteristics that other people don't have to offer, right? If you have knowledge in something specific and the other programmer, has that general knowledge but doesn't have that domain expertise in maybe how to work with React, or how to work, in Angular, or how to build, static websites using, specific tools, they're not going to be as appealing to not just an employer as you are, but they're also going to have a harder time growing because they're not going to know what to grow into. Giving yourself a domain to grow into gives you an easy route of where to go, of how to improve yourself, of what to work on. So I've tried to leave a little bit of time here for questions. I'll be in the Slack channel and in the YouTube chat. Feel free to reach out to me if you have any questions. Feel free to hit me up on LinkedIn, and I'm always happy to talk about these things. And thank you for listening.